And just to remind everybody where things are and going from that perspective, we are in the process of doing our exploring electrostatics, but I do want to remind everyone that they have a test that is due tonight. It's the test on simple harmonic motion and sound. It's in the simple harmonic motion and sound module. And if you click on it here, this is the test itself, but you need to upload the PDF of your responses in this part of the test. If there is any concern or if you're running into trouble with Blackboard, please go ahead and email me a copy of the PDF of the test. I know we've had some weirdness in the internet over the last several days, and people have uploaded items and it didn't upload correctly, or blank pages got uploaded. But if you are concerned, you can go ahead and email me the PDF, because I believe that Blackboard is only going to let you try it once. But I will also be emailing folks if there was any problem with your upload. So just make sure that you guys get it uploaded and we'll go from there. So that's your simple harmonic motion one. In the exploring electrostatics, what I have been doing is just what I did the last for the last group. For our summer class, I've been copying over some of the critical videos that I think you should watch into our summer 2025 folder. That way you know exactly which videos that I think you should watch, and everything else is supplemental because I have so much extra material. So I'm in the process of updating all of that to make it easier for folks to recognize which ones that I'm suggesting that you watch. So we talked yesterday about the powers of 10 and what goes on in your calculator and what WebAssign is doing. I've given you the video notes for working with powers of 10, and then I created a study guide for you for the powers of 10. Our electrostatics introduction, you've got your video notes for that, as well as a study guide. I have put in here copies of the videos that we kind of had talked about yesterday, the comparison of the force due to gravity and the electrostatic force, doing 3 charges in 2 dimensions, doing 2 charges in the determination of acceleration, determining the number of electrons on a charge, and another 2 force problem. So those are in addition to what we lectured over yesterday. Today, we're going to cover electric field, flux, and Gauss's law. Flux and Gauss's law are a little odd to remember and a little difficult to deal with. So I've provided a few things for that. But this is an hour-long video that I have done in the past on electric fields and flux. So it should be a good helper. I will be getting video notes and study guides for it as well, so that you will have that. In here, I have some new resources on electric flux. You have in here, I've got a podcast that's related to electric flux and field. I have the transcripts of that podcast, and I'm asking you all to do this, listen to the discussion and see if it helps or hurts. We tested this out this spring. This is an AI generated podcast, but because flux is an interesting concept, I've tried a couple of different ways to make it easy for people to understand. And so we're looking at it there. And then you have some extra materials on flux. Now, the idea behind flux is really looking at this to help us understand why, if I put an electron into an electric field, it's going to move. and to get a better idea on how fields react through surfaces. Now, we do this to help us derive Maxwell's equations, and Maxwell's equations are really what's important for us to understand electromagnetic waves. So we see it, we hear about it, we do a couple of problems on it, but it's not something that we deal with in a practical sense in the real world. It's something that's there that helps us understand. Now, if you want to get quantum and do other modern physics kinds of things, then flux becomes a really important item. But for what we all do and the area that we play, flux is really there to help us understand why we get the mathematics that we get. So you've got a couple of homework problems on that. You will have a flux problem on an exam. But the critical thing to remember is you only have to worry about the charge inside the surface. So don't make it more difficult than it is. It is just a little bit of a strange concept. So again, we're trying to clean this up to make it a little easier for folks. So that's what's here. And just as a reminder to everyone, the stuff that is due this week is listed in the week 2 plan. That looking at flux isn't due till next week, so it's not on this week 2 plan, but it'll show up on week 3. One last thing, I did put our introductory videos for each of the labs inside the labs themselves, and then I included the video notes. And if you go to YouTube, where all of these videos are, here's our summer 2025 playlist. Let's go back. If I click here, I'll try it. We'll view the whole playlist. There we go. If you go into each one of these labs, like working with the power of 10 or any of the videos, you're going to find, if you go open up the comments, I didn't do it on that one, I guess. There we go. If you go in here, you'll see the comments. And if you read more, those video notes are posted in the comments. So those are there to help folks find things as well. All right. So questions about what's due, where things are. I didn't get too many questions today other than where did they upload the test and when it was due, and then some technical difficulties regarding the test, which were Blackboard didn't upload it very well. All right.